Welcome to the viewers. Today we demonstrate an interesting example of a function which is continuous but not uniformly continuous. For the new subscriber who are watching this video first time, they are advised to subscribe my channel at first and press the bell icon to get all of my notifications of my latest videos and get updates. Let's watch. And we are demonstrating here the interesting examples of a continuous functions which is continuous but not uniformly continuous. Now if we take phi, we define on Q, that is, a Q is a set of rational number, as we know, in the following manner. That is, by definition we are setting here phi x is 1 if x is less than pi, and we consider it 2 as if x is greater than pi, and all of these x are being a rational number. Now let's demonstrate. Here phi is continuous on Q for every epsilon greater than 0, and if we take x0 be any member like x is variable x for the first criteria, first branches of the function, if we take as x0 is less than pi, then we are taking delta is less than pi minus x0 in this manner, that is pi minus x0 is greater than 0, and we take it here as delta, and delta is so small that it is as small as pi minus x0. We take in this manner, and we have here phi x minus phi x0, we consider it, and both of these function is the first branches because we are taking delta as this criteria and x0 is less than pi, so we are taking here 1 minus 1, that will be 0, and we know 0 is less than delta. And however, if we take this difference between x minus x0 is less than delta, we consider it. So it is clear and it's fulfilled the criteria of definition of continuity. So phi is continuous for any x0 with a member of Q. That is a set of rational number, but this x0 must be less than pi. That is, we consider the first branches of this function. Similarly, if we take as epsilon greater than 0, and if x0 is greater than pi, then with delta is greater than x0 minus pi in this manner. Here it will take the second branches of this function, and we can say that we have mod of phi x minus phi x0, that will be mod of 2 minus 2. It's clear we are taking the first branches, that is 2 minus 2, so it will be 2 minus 2, that is 0. Here also you find it's less than epsilon, and whenever mod of x minus x0 is less than delta. So here also phi is continuous for any x0 belongs to Q, but we are considering it x0 is greater than pi. Now we have shown this next criteria. Let's watch. But phi is not uniformly continuous on Q, and if we consider as epsilon be lying between 0 and 1, that is 0 less than epsilon less than 1, what happens? We watch it. For any epsilon greater than 0, we always find that x is less than pi, and taking y as arbitrary variable, y is greater than pi, we take in this manner. No matter for that, we may take any arbitrary variable, but here we take in this way. X is less than pi and y is greater than pi, and such that these differences must be less than delta. We are taking in this manner. And now mod of phi x minus phi y, what happens there? We watch. We already know mod of phi x, that is x is less than pi. We are taking the first branches of the definition criteria as we take in the first page, and here we consider that x is less than pi, so take it will be 1. So it will be 1. Now taking the next stage is phi y, and here y is greater than pi. So it is clear that taking here y, this variable arbitrary, that x is greater than, but if you take it as y, then y is greater than pi. We are taking the value of phi x is 2. That's why we take in this way. So it will be 2. So mod of 2 minus 1, that is 1, and certainly 1 is greater than epsilon, because we are taking here, considering here epsilon is lying between 0 and 1. That's why it is not uniformly continuous, because it doesn't satisfy the criteria we cannot find delta corresponding to this epsilon. So we can say that it is not uniformly continuous. In this way, we end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.